Alright, so we move on to the next scheduling algorithm, which is called priority scheduling. So we've been dealing with a lot of preemptive algorithms where there is a lot of context switch. So I think we will come back to some simpler territory. Non-preemptive scheduling, you pick up a job, you finish it, and then you go to the next job, kind of a thing. So priority scheduling, as the name suggests, is where you schedule tasks not based on their arrival time, not based on round robin, not based on how much time they need to execute, but based on the priority. So every task in this situation, you'll be given the burst time, of course, but apart from that, you'll also be given a priority. So generally we assume the smaller the number, the higher the priority. So a priority value of 1 represents that this task must be done first. Priority value of 2 means this can wait a little bit. Priority of 5 means it can wait quite a lot. So the smaller the number, the higher the priority is the assumption we generally go with. It can also be vice versa. So when you're dealing with priority scheduling, make sure you read the question carefully. So there is every task has a burst time and a priority associated with it. At every step, you pick the task with the highest priority, and by highest priority, I do not mean the greatest number here, but which is topmost priority. So here they say low numbers for high priority, which means this would be the highest priority task here. So in that sense, we pick the most important task at every step. We finish that off fully, then we go to the next task. So for this example, we will first work with process P2 for 1 unit, which is what is happening here, and then process P5 for 5 units, P1 for 10 units, P5 for 5 units, P1 for 10 units, then P3 for 2 units, P4 for 1 unit, P3 for 2 units, P4 for 1 unit. So that is priority scheduling. Because this is preemptive, calculating the wait time and turnaround time is a very straightforward process, which I will leave to you. So this is a very important scheduling algorithm because in a computer you have tasks with different priorities, right? An interrupt and let's say a WhatsApp notification or something like that can definitely not be considered equal priority. A bug in the hardware or a virus or a software update kind of a thing and some notification in one of the tabs which is open are definitely different priorities. So just because this process came first or just because this process needs less time, you cannot blindly execute it always. Sometimes there are more important things, more urgent things to be taken care of. So to make sure that they do not wait indefinitely, we use priority scheduling algorithm. That is the benefit of this algorithm, that the more important tasks are almost instantly taken care of. Now there are a couple more concepts in relation to priority scheduling which I want to discuss. So first thing is the disadvantage of priority scheduling is also the same. The advantage also becomes the disadvantage, because if higher and higher priority tasks keep coming in indefinitely, then the low priority task has to keep waiting. So right now here again we assumed everything arrived at time 0, but you know that is not the case in a computer. Dynamically processes will keep arriving. Now let's say before I start working on this P4, another 3-4 processes come, all of them having priority 4. It is possible for 2 processes to have the same priority, and in such cases you are free to choose any of them randomly, random order. So I have completed up to priority 4. Now I want to start this one, but just then another 3 processes come, all of which have priority 4. So obviously I will work on those 3, and by the time I finish those 3, I have another 2 processes which have priority 1. Then I will start working on those 2, and this P4, this poor process, has been waiting for the longest time and nobody has worked on him at all. So that situation is called starvation, and that is possible in priority scheduling. That's one thing.